Good evening, ladies and gentlemen. Let's watch a little video about simplifying square roots. Keep in mind, simplifying square roots can be much more difficult than what we're going to go into this evening. Before we start simplifying square roots, let's review the definition of a square root. A square root of a number a is the number when multiplied by itself is the number. The square root of number a is the number when multiplied by itself is that number. The square root of a is b if and only if b squared is a. B squared is a. And what we want to note here is b squared is always positive. Therefore, a will always be positive. So let's do a couple quick examples before we get into simplifying square roots. 25. So let's find the square roots of 25. 25 has two square roots. 5, since 5 squared is 25, and negative 5, since negative 5 squared is 25. Both 5 and negative 5 are the square roots of 25. So we need something to denote a square root. The square root of 25, if I use this, and I think most of us are familiar with this notation, the square root of 25. The square root of 25 implies the positive square root of 25 and not the negative. So we want to make sure that we do understand this, that the square root of 25 is 5. If I want to talk about the positive and negative square roots of 25, then I'm going to actually label the square root of 25 positive and negative. And the square root of the positive and negative square root of 25 is positive and negative 5. So I want you always, always, always to remember that the square root of a is always positive, and that a is always positive. Next slide, please. Two important properties of square roots, and we will use these properties to help us simplify square roots. So let's consider the positive real numbers a and b. And we're going to let both of those rascals be positive. A is going to be positive, and b is going to be positive. Both are going to be greater than 0. Property number 1. The square root of a times b is equal to the square root of a times the square root of b. And we're going to call this property 1 right there. Property 2, the square root of the fraction a over b is equal to the square root of a over the square root of b. So these are the two most important properties that we're going to use to simplify square roots. So let's do an example of how we were going to use this. Well, before we do an example, we better review a couple vocabulary words. The radicand. The radicand in this square root expression here, the radicand is a. A is always positive, but a is called the radicand. I will use this vocabulary word in this video. Another vocabulary expression is a simplified square root. A simplified square root, let's get that rascal cleaned up there, please. A simplified square root means that the radicand has no perfect square factors. So the square root of a is simplified if the radicand a has no perfect square factors. So let's look at this term here, perfect square. The perfect square numbers, next slide, please. Here are the perfect square numbers. And this is a good tool to know. This chart is a good tool to know. So here I have the positive integers 1 through 10. Each integer has a perfect square. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, ... These are the perfect square numbers. These are the perfect squares. And so if I go back to my other slide, a square root expression is simplified if the radicand has no perfect squares. Oh my goodness gracious. So here we are right here. Here's my first example. Square root of 75. Square root of 75 is not simplified because if I factor 75, I see that 75 is 25 times 3. 25 is one of those perfect square numbers. So therefore, I'm going to use property number 1, and I'm going to say, excuse me, the square root of 75 is equal to the square root of 25 times the square root of 3. Why? Because 25 times 3 is 75. The square root of 25 I know is 5. So the square root of 75 is 5 square root of 3. This is the simplified version of the square root of 75. And I use property 1. The square root of a times b, this is on the product, is square root of a times square root of b. And then I'm going to simplify this perfect square root. How about the square root of 28? The square root of 28 is not simplified since 28, the radicand, is 4 times 7, and we see here that 4 is a perfect square. So how can I simplify this square root of 28? The square root of 28 is simply the square root of 4 times the square root of 7, property 1. And the square root of 4 is 2. Square root of 4 times 7 is 2 times square root of 7. So this rascal is square root of 28 simplified, because 7 has no perfect squares. So let's do a couple simple examples. Here's my tool that I'm going to use, my list of perfect squares. And if I look at square root of 108, I want to simplify the square root of 405, and the square root of 63. I'll give you a moment, pause the video, see if you can figure out if these are perfect squares. Use a calculator if you must. And see if 108 has any factors that are perfect squares. See if 405 had any factors that are perfect squares. And see if 63 has any factors that are perfect squares. Next slide, please. And we see 108 is 36 times 3, so the square root of 108 is the square root of 36 times the square root of 3. Square root of 36 is 6, because 6 squared is 36. So the square root of 108 is 6 square root of 3 in simplified version. 6 square root of 3 is the simplified version of square root of 108. And when I notice that 405 is 81 times 5, I think that was an easy one to see, an easy one to factor. And the square root of 81 is 9. So the square root of 405 simplified is 9 square root of 5. And in like manner, It's certainly easy to see that the square root of 63 is equal to the square root of 9 times the square root of 7. The square root of 9 is 3. Therefore, the square root of 63 is the 3 times the square root of 7. Next slide, please. Here's another important property of square roots, or one that we will use quite often. The square root of a times the square root of a, it's actually the same property that we've been using, property 1, because a times a is a squared. Well, in the square root of a squared, what squared is a squared? A. So therefore, square root of a times square root of a is a. Star that because we're going to need to know that. Square root of 7 times square root of 7 by property 1 is the square root of 49, and the square root of 49 is 7, because 7 squared is 49. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3, because 3 times 3 is 9. 3 squared is 9. You can leave this step out here if you have this. Square root of 5 is square root of times square root of 5 is just 5. We will need to know that. Let's go to our last few examples for this video. In the olden days, a simplified square root expression was not allowed to have any square roots in the denominator. So this used to be an old rule of thumb, and we will adhere to this old rule of thumb. We will continue to adhere to this old rule of thumb, but note that mathematicians are not as strict about this as they used to be. So no square roots in the denominator of an expression. Here I have an expression. 1 divided by the square root of 3. Can I write this with no square root in the bottom, in the denominator? Well, yes, I can. And what I'm going to use is I'm going to use this very important property from algebra that says a times 1 is equal to a. So I'm going to multiply this 1 over square root of 3 times 1 disguised and rewrite it. But this is the property I'm going to use. So look at here. 1 over the square root of 3, if I multiply that by square root of 3 over square root of 3, this guy right here is just another word for this is 1. This is just a 1. Something divided by itself is 1. So if I'm going to multiply this guy times 1, this is going to have the same value. A times 1 is a, same value. And how do I multiply fractions? I multiply the top. 1 times square root of 3 is square root of 3. And square root of 3 times square root of 3 is 3. And I note here that this expression does not have a square root in the denominator. So therefore, 1 over square root of 3 can be written as square root of 3 over 3. These are the same value. In like manner, if I want to simplify or write this expression here, 5 over square root of 2, without the square root in the bottom, I'm going to multiply this rascal by 1. But what 1 am I going to use? I'm going to use this 1 right here, the square root of 2 over the square root of 2. Why? Because the square root of 2 times the square root of 2 is 2. Now I don't have a square root in the bottom. 5 times square root of 2 is simply 5 square root of 2 over 2. So what do I know? I know that this 5 over the square root of 2 is the same thing as 5 square root of 2 over 2. Same expression. They don't look the same, but they mean the same thing. Mean the same thing. So let's try these. Pause the video, and let's see if we can simplify these expressions. Pause the video. Okay, here we go. So I think it's easy to see. I'm going to multiply this by 1. And what 1 am I going to use? I'm going to use square root of 3 over square root of 3, because I notice the square root of 3 times square root of 3 is 3. Now the square root is out of the bottom. And the top is simply going to be 7 square root of 3. So these have the same exact value. 7 over square root of 3 is the same as 7 square root of 3 over 3. In like manner, I'm going to multiply this rascal by 1. I'm not going to change it. I'm going to use that property from algebra. A times 1 is A, same value. And what 1 am I going to use? I am going to use this 1 right here. Square root of 5 over the square root of 5. 2 times square root of 5, multiplying the top is 2 square root of 5. And square root of 5 times square root of 5 is 5. So this 2 square root of 5 over 5 is the simplified version of 2 over square root of 5. So this is simply just simplifying square root 101. Have a good evening.